Okay, we're going to talk a little bit more about eliminating parameters. So this problem is actually number 15 on the worksheet that we've been doing, so that you don't write it like down not on that worksheet. It says eliminate the parameter and write the standard form of the rectangular equation. And then it says the line through x1, y1, and x2, y2. And then it gives us these two parametric equations. Well, how do we eliminate the parameter for most parametric equations? We solve for t. So let's do that with the x equation. Let's solve it for t. So let's subtract x1 over. Gives us x minus x1 equals t times x2 minus x1. Then I can, to get t by itself, divide both sides by x2 minus x1. Okay, and so that gives me t equals x minus x1 over x2 minus x1. So now let's plug that in for t. We get y equals y1 plus, where t is, I'm going to put in x minus x1 over x2 minus x1, and that's multiplied by y2 minus y1. Now, if I do a little bit of manipulation on this, if I manipulate it, then I can end up with basically point slope formula. If I subtract y1 over to the other side, so y minus y1, that looks like the left side of point slope. Now, if I look at what I have here, let's think about if this was a fraction. Let's make it over 1. I can switch these two numerators around. Okay, I'm allowed to do that because that is multiplication on top. Multiplying two numerators together, you can switch them around and still have something that is valid. Okay, and so notice that if I put this top here on top of this fraction, this is the slope formula, y2 minus y1 over x2 minus x1 times x minus x1. Okay, this is basically point slope form. Actually, it is point slope form, not basically, it is point slope form, except a lot of times we put an m here instead of actually writing out the slope formula. So that's what it's asking us to do. So let's talk about what 16, 17, and 18 are going to be like, because we don't have t's, we have thetas. This is going to work similarly to problems 12 and 13, where we want to start off by, like on this one, we would want to start off by subtracting h and subtracting k, and then if we square both sides, we'll end up with an identity. Okay, and keep in mind, our goal is to get the standard form of a circle. So if you happen to know what standard form of a circle is, then you'll know if you got it right or not. For ellipse, we would do the same thing. We would subtract h and subtract k, but this is like on 13. Not only do we want to do that, but we would also want to divide by what's in front, this a right here, so that we end up with x minus h over a equals cosine theta. And then we do that with sine as well. And again, we're going to end up with an identity. And same with the hyperbola. We're going to subtract h and divide, and then look up what this identity with secant and tangent was and see if you can see what's going to be different between the standard form of an ellipse and a hyperbola. So that's what's going on with those. Then on the back of this worksheet, 15 through 18, wants us to find the parametric equations for the line or conic. Now it says x1 and y1, which is kind of confusing because we were just dealing in our previous formulas with x1s and y1s, so just think of it like an x and a y. If we're passing, and this is not actually one of these problems, so I'm just showing you an example because I don't want to deprive you of having to do a problem yourself since there's so few of them on there. Let's say that this is x1, y1, x2, y2. If you flip over to the front where you have the equation we just came up with for a line, well, we don't really want to use that one. We want to use actually what the problem was we started with. This is 15. since we know that this worked out to be the equation of a line, we can now use this to say, hey, if I have the equation of a line, or if I have 2 points that make an equation of a line, that means I can plug them in and I can get 2 parametric equations. So, like if this is x1, y1, x2, y2, then I'm going for x equals to put x1, which is 2, plus t, and then x2 is 4, x1 is 2. So if I simplify this, that would just be 2 plus 4 minus 2 is 2t. Okay, and then I can do the same thing for my y. y1 is 3 plus t, and then 6 minus 3, which simplifies to be 3 plus 3t. So these are my 2 parametric equations for the line that passes through those points. Okay, so let's look at, like the circle one's going to be pretty easy because the center point of our circle is h and k, and our radius is r in our standard form or whatever. Okay, so with ellipses, it gets a little bit trickier. This is not the same problem as what we have, but it's close. This is our A for our formula, and this is our C. Down at the bottom of our worksheet, we have this helpful hint that if we know 2 of these, we can find the other. If I know that A is 8 and C is 6, we're going to drop the plus or minus because we're about to square and that's going to get rid of it anyway. So 6 equals 8 squared minus B squared. Not 8 squared. Yeah, 8 squared, which is 64. Oh. Haha, so 6 squared. Let's try this for real. 6 squared, so that's 36, equals 8 squared, which is 64, minus b squared. Okay, so I'm going to subtract 64 over to the left side. 36 minus 64 is something. 8, negative 28. I'm sure if that's not right, you guys will tell me tomorrow. 28 equals b squared. Square root both sides, so b equals the square root of 28, which is 2 square roots of 7. So if I am looking at I'm looking at problem number 17. If I want to write this with parametric equations, I'm going to use that, because we know that this ends up being an ellipse. We worked out that that's what it was. Okay, so also the ellipse and the hyperbola are centered at 0, 0. Okay, so there's not really going to be an h and a k. Our a is 8, so this would be x equals 8 cosine theta. Y equals, our b is 2 square roots of 7, so 2 square roots of 7 cosine theta. Something like that. Okay, the one on the worksheet, it's a little nicer. It doesn't end up being square roots. So the hyperbola. Now hyperbolas, if you remember, were these things where like we drew a box. We'll do this later on in the semester. We drew a box, and a hyperbola can go this way, where it's like this. When it does that, it's something of the form x squared over something minus y squared over something. The x goes first and there's a minus sign in between. If we have the parabola part of the graph, like the u and the n, if those are on the y-axis, if they're opening up and down, then we would have y squared over our number minus x squared over our number. So let's first off, what did they have on 18? X equals h plus a secant theta, and y, that's supposed to be an equal sign, k plus b tangent theta. And so, again, I'm centered at 0, 0. And A is going to be this. C is going to be this. We can use this to find B. So 3 squared equals 2 squared plus B squared. So that's 9 minus 4. So that's the square root of 5 is B. But the thing is that this is like set up so that we end up with x minus y, x squared minus y squared. Because look at what you got. Well, when you do it, look at what you get for the standard form. If we think about vertices at plus or minus 2 on our y, that's like a vertices here and a vertices here. So what we need to do is put y first. We're going to have y, well, if we were writing this as a standard form, we would write it with y squared. Underneath the y goes a squared, which in this case is 4, minus x squared over b squared, which would make that 5 equals 1. This is like the standard form of that, of this equation, but that's not what we want. We want the parametric equations. All I'm trying to get at on this is that we need to switch these around, that we would have x equals b tangent theta and y equals a secant theta because of the fact that my vertices are on the y-axis. That's what makes us switch. So x equals b is square root of 5 secant theta, y equals 2 tangent theta. Okie dokie. Done.